All right, on to 8.5, which is the Cartesian equation of a plane. We did vector equations, we did parametric equations, and now we are on to Cartesian equations. Also going to be very easy. So the Cartesian, which is a scalar equation of a plane in 3 space, is, you know, this is like standard form, like forever, like from quadratics to cubics. It always looks like this, right? X, Y, and now we have a Z, and then plus some sort of constant D equals 0. Where the normal, the vector of the normal is actually the numbers a, b, and c. So the numbers in front, the coefficients in front of x, y, z, are the normal to this plane. That's big. So this normal is perpendicular to all vectors in the plane. So a normal is just a perpendicular something. So this marker is normal to this marker board. Okay, so this is really important. So we want to be able to determine the equation, the Cartesian equation of the plane containing these 3 points. So very easy. We know how to do this already because we know how to find a normal. You maybe just don't know it right now. So I have to find a normal to the plane where AC and AB lie on. I got 3 points. First thing I'm going to do is I'm going to find 2 vectors. AB. AB is 4, 0, negative 1. 4, 0, negative 1. And I'm going to find AC. AC is going to be 1, negative 5, 1. Negative 1. Okay, now I have 2 vectors. With 2 vectors, I can form a plane. And we know how to find a perpendicular vector to that plane because we learned that already. That's the cross product. So if I have 2 vectors and I do the cross product, I can find a perpendicular vector to that plane. And this blue marker, this normal, is just going to be the coefficients a, b, and c. And that's it. It's really easy because it tells me the normal. So what do I got to do? You got it. Cross product. I have to do AB cross AC. However you do the cross product is up to you. I'm going to start with 0, negative 1, 4, 0, and negative 5, 1, negative 1, negative 5. I got to cross, I got to cross, I got to cross. So my first one is 1 minus 5, negative 4. 0 minus 5, negative 5. I got 1 minus 4 is negative 3. And I got negative 20 and 0, negative 20. This vector is perpendicular to all the vectors at these 3 points, the plane that it makes, because I just did the cross product. So these are the coefficients in there. So I can say, well, so far I know that negative 5x minus 3y minus 20z plus d equals 0. So this is where I'm at so far because I have the vector. I need d. Well, that's easy because I have 3 points on here. So I can use one of them, replace x, y, and z, and solve for d. So that's it. Let's go here. I'm going to use the first one. I select 1s, 2s, and 5s. That's pretty good. Negative 5 with a 2 with a 5. That's a 5. That's a 6. That's 100. And that's d. That's negative 101. So d equals 101. And now my final answer, the Cartesian equation of a plane. Therefore, negative 5x minus 3y minus 20z plus 101 equals 0 is my Cartesian equation of this plane, where negative 5, negative 3, negative 20 is perpendicular to this plane. Cross product. Easy stuff. Okay, so next examples. The first one is we have to come up with the Cartesian equation for the plane when we have the vector equation. Also very easy. Doesn't get really tricky until you have to go the other way around. That's what we usually do in math, right? We go one way and then we learn how to go backwards, and the backwards is generally a little bit more difficult. So here's my vector equation of the plane. I have 2 directions and a point, like I know I should have. But for the Cartesian equation, I need a normal. Super easy again. When we had 3 points, we came up with 2 vectors. Then we did the cross product of those 2 vectors for the Cartesian equation. Well, we already have 2 directions because we have the vector form of this plane. So if I just do the cross product with these two and then plug in the only point that I know, I can find A, B, C, and D. And that's how easy it is. So I have to cross these guys like that. So I can say 1, 0, 2, cross -1, 3, 4. I'm just going to skip to the answer here because we kind of already know how to do this. And I'm going to reduce this. If you ever get a multiple, you should always reduce it. This is going to be a 2, 2, -1. I'm going to take out that -2. And I can put the -3 in front if I want, but it doesn't really matter. Okay, so now I have my vector of my coefficients. So I have 2x plus 2y minus z plus d is 0. I'm going to plug in the only point that I have. Remember, these are directional vectors, and this is a point. So I'm going to have 2 times 1 plus 2 times 2 minus -1 plus d is 0. That's 2 plus 4 plus 1 plus d is 0. This is 7, so d is -7 when I bring it over. Done. Do it in orange again. Therefore, my Cartesian equation is 2x plus 2y minus z minus 7 equals 0. And I found the Cartesian equation of this plane. Easy. Backwards. Determine the vector and parametric equations of the plane when I have that perpendicular vector. It's a little trickier. We have more options here, right? We have 2 directions and a point. Over here, we just have the normal. So obviously it's harder when we're starting with less information. So backup plan. Number 1, you could just find 3 points on this plane, and with 3 points, you're able to do the same thing that we did in example 1. Okay, so there's no excuses on not knowing how to do this. You can just plug in some points, figure out x, y, z 3 times, and then you can use 2 directional vectors and you're done. Or, this is a little bit more complicated, but you can do it this way. I can replace the y with s, the z with t, my parameters, and then I'm going to solve for s. So what this does is it turns all of my letters into the parameters because I'm going into parametric equations. So what's going to happen here? So therefore, my x, y, z are going to be 2s minus 5t plus 6. That's my x value right there. My y value is just s, and my z value is just t, because I just did this. And this is my new x, y, z. Okay, so this is going to be, this first point is going to be not s and t, right? Because s and t follow after. So I just need the constant here, 6, no constant, no constant. So my point is actually going to be 6, 0, 0. Or you can plug in s and t as 0, and you get 6, 0, 0. Plus, now I'm going to use my s's. I have a 2s here, I have an s here, and I don't have an s here. Next, I'm going to use my t's. I have -5t here, I have no t here, and I have a t here. Okay, so it's kind of hard to see, but I'm just using the constant for the first point, the s's for the second point, or the directional vector, and the t's for the third one, the second directional vector. And now I can factor out my parameter. I'm going to take out an s over here, and I get 2, 1, 0. And I'm going to take out a t over here, and I'm going to get -5, 0, 1. And this is my answer. That is the vector equation of my answer. You want your parametric equations, same deal as always. It's going to be 6, plus 2s minus 5t. I already had that one. Y is going to be s, and this is going to be t. Right? We already did that though. The parametric equations were kind of done at the beginning. So this was a waste of time actually. All right, we have a few more examples to do. It's going to be a long lesson. Okay, second last thing we have to do is talk about parallel and perpendicular planes. So planes that are like this and planes that are like this, parallel and perpendicular planes. So 2 concepts we have to know. If 2 planes, pi1 and pi2, are perpendicular, then their normals, n1 and n2, these 2 vectors, have a dot product of 0. So if I have a plane and I have the normal, and I have another plane, I have its normal, the normals will have a dot product of 0. Very important. Parallel, on the other hand, if 2 planes are parallel, then one normal is going to be a scalar multiple of another. So if I have like 1, 1, 1, 2, 2, 2 is a scalar multiple of 1, 1, 1. So here I'm going to show that this plane and this plane in Cartesian form, these are perpendicular to one another. And the way I can do that is by finding the normals. Well, I have one normal, n1 is just 2, -3, 1. And I have my second normal over here is 4, -3, -17. I have my two normals. Now I'm going to say, well, is n1 dot n2 0? Well, let's see. 2, -3, 1 dot 4, -3, -17. I'm going to do my dot product, so 2 times 4 minus 3 times -3 plus 1 times -17, and my dot product is indeed 0. So I can say, therefore, pi 1 is perpendicular to pi 2 because the dot products of the normals are 0. Simple, dot product, bring it back. Next, parallel, kind of the same thing, even easier. I can just find the normals, n1, n2. So notice that when we're dealing with Cartesian equations, we're really dealing with the normals a lot because of the equation being formed with the normal. So you're always using the normal, n1, n2, blah, blah, blah. So write down your two normals. I got 2, -3, 2. And I got 2, -3, 2. They're the same. The only difference here is this constant over here. So now I can conclude that they're actually parallel already. So I can say, therefore, n1 is parallel to n2. Now, I can't just say this. Well, I can say because n1 equals kn2. It's a scalar multiple. It's actually the same. The k is 1. Doesn't really matter. They're exactly the same. But it's really important to note here that they are only parallel because these are different. Otherwise, they would be the same plane and they wouldn't be parallel. So keep in mind that just because they're parallel, you got to look at that d value to make sure that they're actually different planes. They're not coincident. All right, that's it. Perpendicular and parallel. Last, we're going to do angles between planes, and we're done 8.5. Okay, lastly, you're going to have to find the angle between intersecting planes. So if these planes intersect, at what angle are they intersecting? Is it 90 degrees? Is it 30 or 120? Whatever the case may be. Sorry, 30 or 150. We have to know where they're intersecting. Not where, the angle. So you have to remember this. We know this. This is dot product. We know this formula. So cos of theta, this is how we find the angle. We have to bring back a formula that has theta. So this is the one. And if I'm using Cartesian equations, then I can use the normals to figure out the angle of the intersection of the planes. So if I have to determine the angle between these two planes, I come up with my two normals. So my normal 1 is 1, -1, -2. And my normal 2 is 2, 1, -1. I have my two normals. I can pretty much do this immediately. First of all, let's do this, because this is so easy. Square, 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 add them, root 6. Square, 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 4, 1, 1. 4 plus 1 plus 1 is 6, root 6. So I found the magnitudes. I'm done. Cos theta equals the dot product of these guys, 1, -1, -2, dot 2, 1, -1, over root 6 times root 6. This is going to become 1 over 2. And theta, when cos theta is 1 over 2, theta is either going to be 120 or 60. It's got to be both. It's got to be both, because if it's 60, then the other side, the supplementary angle, it's not based on this. It's not based on the casserole, sorry. If one is 60, then the other is 120, right? If this is 90, there's 90 on both sides. But if it's 60, on one side it's 60, on the other side it's 120. So technically both are the correct answer, because that's the angle that the planes intersect. If it asks you for the acute angle, put 60. If If it asks you for the obtuse angle, put 120. You want to be safe, put both. And that's it. Angle between two planes. Done. Chapter 8. See you later.